definition of the probability, and which states that the probability of an event is the ratio of two numbers, the size of the event and the sample size. And we had done various examples, and I had also given you one advice that most of the time the problem is not related to the application of the definition of the probability, but the problem is linked with the counting as to what is the size of the event or what is the size of the sample space. Then we had seen another law of the probability, which is like the union of two events. I mean, the probability of the union of two events. And we had proven it pictorially with the help of the Venn diagrams that if I am looking or if I am interested in finding out the probability of the union of two events, it is equal to the sum of the individual probabilities minus the joint probability. And in case the two events are disjoint, so A intersection B is going to be an empty set, so this number is going to be 0 and it won't participate. And lastly, we had seen the definition of the conditional probability as to what does that mean. Okay, fine. Ikra, Batul and Muhammad Sadiq Khan, I think if you do not have any questions, you can mute your mics. As soon as you have a question, you can unmute it, and that would be better. It is for everybody. If you are not asking a question, please keep your mics muted. Okay, Sadiq. Okay. So here we are with the definition of the conditional probability, which states that the conditional probability of the event A given the event B is the ratio of two probabilities, the joint probability of A and B, and the individual probability of the event B. Okay, fine. So then we had seen, or I had told, yeah, I told you guys that mathematically speaking, this is an equation, and I can isolate the joint probability, which I have done it over here on the right. So when I isolate it, I can see that the joint probability is the product of two probabilities, the probability of the event B and the probability and the conditional probability of the event A given B, which can equally or equivalently be written as follows. Since I am writing the joint probability of A and B, so I should not have any preference for writing the individual probability of the event B. I could have written the individual probability of the event A. So that means I can equivalently write the same statement as follows, that the joint probability of the event A and B is equal to the product of the two probabilities. One is the probability of the individual event A, and the second one is the conditional probability of the event B given A. So that's how I am going to write it. And a very tricky thing that happens, that in performing calculations, it seldom happens that we need this definition for the, just a second, let me see if I can okay, yeah, we seldom need to apply this boxed definition for calculating the conditional probability. It seldom happens. So we somehow or the other, we know it. Okay. So however, when it is written in the equivalent mathematical form, we do use such an expression to calculate the joint probabilities. So we would be using one of these two expressions for the joint probabilities. Let me highlight this one with some other color. Yeah, this one would be used to calculate the joint probability. Let's have a look on the example wherein we are going to find the joint probability, or wherein we are going to use this expression. Okay. So here I have a question. It is from the same book. Yes. Yeah. Okay, please read this statement. I give you something like 2 minutes. Try to understand what this statement is trying to say. I hope that you are done reading the statement.
Yes, sir.
Yes,
Okay.
sir.
Okay, great. Thank you very much for the feedback. Okay, now let's see how many parts or what are the, okay, we are given, we have some information. So what are the components of that information? So what information do we have? That over here we have got a few juniors. There is some course wherein we have got a few juniors. To be exactly speaking, there are 10 juniors in it, and there are 30 seniors in it, and then there are 10 graduates. Fine. So in total, we have a class of size 10 plus 30 plus 10, which is 50. So there are in total 50 students in that class, which is the advanced physics. And then after the exams, it is observed that the A grades distribution is as follows. That 3 of the juniors got an A grade, 10 of the seniors got an A grade, and 5 of the graduate students got an A grade. Fine. So this is the information that we have. Now it says that if we randomly choose a student, then uh, and then we find that the student has gained or has earned an A grade. So what is the probability that the student is a senior? So this is what we need to find. So whenever we have such a situation, we will try to write the given information in the terms or in the language of the probability theory. Um, let's see. So my event or my experiment, rather, yes, my, it's not my event, my experiment is uh, randomly choose one student from this lot of 50 students. Fine. So I can write a few events. For example, uh, if I say let J be the event that the randomly chosen student is a junior. You know, we have a strength of 50 students and I'm randomly selecting one student. So that student can be a junior, and let S be the event that the randomly chosen student is a senior, and respectively G be the event that the randomly chosen student is a graduate. And if I ask you about these probabilities, definitely you would be able to give me the answer. For example, if I ask you what is the probability that the randomly chosen student is a senior, so what you have to see, we have to see, okay, how many students are there in the total lot. So how many students were there? I just simply, yes, how many students are there? Somebody?
30 students, sir.
30,
Okay, there are 50 students in total.
50 students.
No, sir, total 50, but seniors are 30.
Seniors are 30. So this means that if I am randomly choosing one student out of the lot of the 50, so the probability that the randomly chosen student is a senior is 30 by 50. Agreed? Because I don't
Yes.
have,
Yes, sir.
yes, I don't have to look at their rank. I just have to pick randomly. So therefore the probability of choosing of a senior student is 30 by 50. Fine. Okay, then as per my information, 10 of the A grades were belong to seniors. Okay, so by the way, if I just ask you another question, so what is the probability that, let A be the event, that the randomly chosen student secured an A grade? So can you tell me how many total A grades are there?
18.
G?
18 over
18.
50.
18, exactly. So the probability that if I am randomly choosing a student, the probability that the chosen student would have earned an A grade is 18 by 50. Do we all agree? Because in total there are 50 students and in total there are 18 A grades. So therefore the probability that I have randomly chosen a student has earned an A grade is 18 by 50. Okay. Now the thing is, I have one information with me. And what is that information? That out of these 18s, 10 of the A grades are with the seniors. Okay. So that means that means that the conditional probability of an A grade given a senior student was selected is equal to 10 by 30. Do we all agree with this?
Yes, sir.
Yes, sir.
Okay, isn't it? I know that in total there are 30 students, and out of those 30 students, 10 of them has earned an A grade. So if my sample space is reduced to the senior students, so the probability that a randomly chosen student would also have earned an A grade is 10 by 30. Okay, so this is the information that I have with me. Now, the question is a bit different, and that is what I want to state. I want to state that, and it's already stated over there, but I want to write it. And what is that saying? Let me write it again. Not again, let me write it for the first time. I'm looking for this probability. It says that, okay, I randomly picked a student and found out that they have earned an A grade. Now, what is the conditional probability that they are from the senior batch? So I'm looking for this conditional probability. Okay, so what is the conditional probability of selecting a senior student given that the selected student has earned an A grade? Now, this is something which is not here in this question, or not available, directly accessible in this question. So the rest of the story is there in front of me. Now I would have to invoke the definition of the conditional probability, and and probably in its alternative form. So if you look at the box over here, wherein I am stating that the joint probability can be written as the product of two probabilities. So it eventually means that these two things are also equal. That the probability B multiplied by conditional probability A given B is the same as the probability of A multiplied by the conditional probability of B given A. So if I apply this definition to my problem over here, I can write something as follows, which I'm going to write in a different color. And it would say that the probability S multiplied by the conditional probability A given S is the same as individual probability A multiplied by the conditional probability of S given A. Isn't it? I'm just rewriting that statement in this form. And now I want to see if I have the relevant information in it. So I will have to get back and see if I have those things with me. Do I have probability of S? Yeah, do I have it?
Yes. Yes, sir.
Yes, of
Yes, sir.
course,
You
which
have.
is 30 by 50. Do I have probability of A given S?
Yes, sir. 10 by 30.
Yes, sir.
Exactly, 10
10 by
by 30. Nice. Equality. Do I have probability of A?
18 over 50.
and I am looking for the conditional probability, which I will keep as it is. Fine. Can I find this the number now?
Yes, sir.
Of course, I can find this number. So what will I have? 50 cancels 50 over there, 30 cancels 30 over here, and I am left with this thing, that the conditional probability of S given A is equal to 10 by 18. So that is my answer. So you see that the general procedure for addressing a problem related to the probability theory is linked with writing the information in the language of the probability theory, and also writing the problem statement or what is required from us in the language of the probability theory. So once you write it up, then you have to look for the corresponding tool to help you. In this case, we have, what is the corresponding tool? By the way, what are the components of the information that are available to us? Please tell me. Anybody? Come on.
So probability of senior
Cheek.
students out of
Yes.
the total sample space, and the
Yes.
probability of the students or the total students that got A grade out of
Yes.
yes, and the probability that number of students that got A grade out of the total
Seniors.
senior students.
Okay,
Yes.
fine. Very nice. Very nice. Who is this? Who spoke? Who gave me this answer?
Waleed Ahmed.
Okay, Wali. Thank you very much for your participation. Okay, guys, look at this thing once again. We also have some information which was not helping us out in finding the answer to what was desired from us. So we were to find the conditional probability of S given A. However, we have seen that there is multiple information given to us. I mean, I did not go for the probability of selecting the junior student. I did not go for the probability of selecting a graduate student. I did not go for the conditional probability of an A grade given a junior is selected or a graduate is selected. So I have that information with me, but I have not written it down because it was not participating towards my objective. And what is the probability tool that I have used in finding out the information required from us?
The conditional probability.
The definition of the conditional probability or its alternative form. Very nice. So most of the time, this is the framework for addressing or for solving problems related to the probability theory. I have one more notion, which is, I mean, talking about the conditional probability is incomplete if I don't talk about one concept, and that concept is called, let me write it down, and that concept is called the stochastic independence. Okay.
सर वैसे ये कंडीशनल प्रोबेबिलिटी के बगैर भी हम सोल्व कर सकते हैं ना इसको, क्योंकि हमें वो इंडिविजुअल उन्होंने बताया हुआ है कि जूनियर्स को कितने ए ग्रेड मिले हैं, सीनियर्स को कितने, और ग्रेजुएट्स को कितने.
No, we can't. We can't. We have to invoke the definition of the conditional probability and its alternative form and the equivalence between the alternative forms. It can't be solved otherwise. I need this information as given A, and I have the other of the information. So this is the only tool wherein all of these are linked with each other. So the answer to your question is no. We can't find it without invoking the conditional probability. Let me write something about the stochastic independence and then we can move on. For describing the stochastic independence, I would give you an example. Okay, here is my example. Now, in this example, I have one experiment, and that experiment is of the kind wherein I toss a coin a fair coin, I would say. And I would roll a fair die. So this is my experiment. And if I ask you for the sample space, so you guys would agree with me that the sample space would consist of, say, okay, a coin can have two possibilities, heads or tails, and there are 6 possibilities for the upward face of a fair die, isn't it? So
Yes.
if I look at, and sample space means the totality of all the possible outcomes. So I can write my sample space as H1, H1, H2, H6, T1, tail 1, tail 2, tail 6, isn't it? These are all the possible outcomes that I can have from this experiment. Do you guys agree?
Yes.
But this
Nothing
tail
nothing
1
is
to 6
missing.
is a bit confusing.
Nothing is missing. Everything is there. And
Yes.
H1, H2, H3, it means that the coin shows heads and the die faces 1 upwards. The die faces 2 upwards, or the die faces 6 upwards, and so on and so forth. Now I've got 2 events. Let me write them down. My event A is that the coin shows heads. And my event B is that the 6 appears on the die. Okay, so and then I ask you list A. So you would say, well, I can list A. List A will be equal to coin shows heads. So I will have H1, H2 till H6. Do you guys agree with me? That's how I'm going to list A.
Yes.
And if I want to list
Yes.
B, can you guys help me in listing B?
H6.
H6,
H6,
huh?
T6.
T6. Fine. So we all agree over here. And then I ask you this question. The probability of the event A, what would be your answer?
6 by 12.
Very nice. And what about the probability of the event B?
2 by
2 by
12.
6.
2 by 12. We all agree with that. Fine. Now I'm going to write it in another. I'm going to ask you one more question. Probability, conditional probability of A given B.
One by
1 by
H6.
सर H6 है तो हमारे पास 1 by
Okay, if things are creating trouble, you can always use the definition. So what is the definition?
1 by 2.
I think this is the definition.
Yes.
You have to apply the definition of the conditional probability. Okay. Now probability of A intersection B, the joint probability, which means that, okay, what are the common elements between A and B? So they have got only one element in common, which is 8, 6.
Yes.
Agreed? So I'm going to
Yes.
write 1 by 12.
12.
Yes, sir.
Okay. And how about this B? Which has already been
1 by
calculated. 2 by 12.
1 by
2 by
6.
2 by 12. 2 by
So what is the net answer?
1 by
1 by 2. Very nice. Very nice. Now I'm going to ask you another question. The conditional probability of B given A. Yes, please.
1/6.
No, just there. Why don't we just apply the definition? With the help of practice, everybody would be able to write these things directly without invoking the definitions. Okay, so which is the it is 1/12. We keep it as it is, and A is 6/12,
6/12.
and which is equal to
1/6.
1/6. Very nice, very nice. Now look at what we have obtained. B given A is 1/6. No, what happens? Just a second, please. Yeah, is 1/6, and the probability of B is also 1/6,
2/12.
which is 1/6. Which is 1/6, agreed?
Yes, sir.
Good. The conditional probability of A given B is 1/2.
Yes. Yes.
And the probability of the event A itself is
It's 1/2.
also 1/2. So now you see that it is not a coincidence. Somewhere earlier in my discussion, I said that the conditional probability helps you out in gaining certainty about something. But in this scenario, the individual probability and the conditional probabilities are the same. What do I mean by that? Let me write it down. That the probability of the conditional probability of A given B is the same as the probability A, and the conditional probability of B given A is the same as the conditional probability of the event B. Now it means that the occurrence of event B does not alter the probability of the event A, and the occurrence of the event A does not alter the probability of the event B. And that further means that if I am interested in finding out the probability of the event A, it does not matter whether B has occurred or not, which means that the probability of A or the event A is independent of the event B, and vice versa. Event B is independent of the event A. If something of this type happens, we say that the two events are stochastically independent. So how do we define the stochastically independent events? We define them mathematically in this form, that the individual probabilities and the conditional probabilities are the same. Number one, or equivalently in words, it would mean that the if occurrence of an event does not affect the occurrence of another event, so the two events are said to be mutually independent or stochastically independent.